Here's our second job of the day. This is an Indramat Servo motor, and it is model number MDD071-N-060-N2S-095PA2. That's a long part number right there. Their complaint had this little label on it. It says, no drive fault, just machine fault. And that was attached to this motor right here. So they had no faults on the drive, no faults displayed on the 7-segment display of the Indramat Servo drive, but the machine said there was a fault. Now I'm curious what the machine said, because this label just says, just machine fault. So here are the power connections. Face this to you. There's a mechanical brake. I cannot rotate this motor. There's a mechanical brake that we're going to have to release. And according to the pinouts, I'll put this up at the end of the video so you can see it, but according to the pinouts, F and G are the mechanical brake. We're going to apply plus 24 volts DC positive to F, and that ground of the same 24 volt DC power supply to G. And right up here is F and G. It's labeled A, B, C, D, E, F, G, H, starting from the keyway and moving clockwise. Here's a diagram of our connector right there. A, B, C, and D are A1, A2, A3, and frame ground. That would be UVW, frame ground. There's a thermal on H and E of this connector. Now let's get closer and we'll measure these resistances with our meter. Okay, let's set our meter to ohms mode. And according to the diagram, A, B, C, and D are A1, A2, A3, and frame ground. Let's check D. D is the longest pin of all. Now I'm going to go to the case of the connector, and we're going to get on pin D. There we go. We got 0.2 ohms. And that 0.2 ohms is the resistance of my meter leads. So if we subtract that 0.2 ohms from what we read, we have 0 ohms. Now let's go to A1 and A2. I'm trying to reach around the camera here. Here's pin A to B. Let me get this way. I'm going to get in the way, but you know I'm on the pins. So there's 0.4 ohms. The winding resistance of U and V would be 0.2 ohms if we subtract my meter leads. Now we're going to go pin A to pin C. That would be U to W. And again, we read, get on there, slipping off, we'd have 0.2 ohms. Now let's go to pin B to C, and we should have the same reading. There we go, 0.4. Let me get on it like this. It's aggravating when my pins don't want to get in there and stay. We'd have 0.4 ohms minus my meter leads. Again, we measure 0.2 ohms on V to W. A1, A2, A3, and frame ground. Now, let's measure the mechanical brake resistance. And that is on F and G. So we go A, B, C, D, E, F and G. An electromechanical coil for the brake is 46 ohms on this motor. Okay, now let's measure the PTC, the thermal. That stands for positive temperature coefficient, and that's on pins H and E. So we have A, B, C, D, E, F, G, H. Let's see what we measure on that thermal. Stay on there. I gotta go back to meter school, learn how to use these probes. They keep slipping off. Alright, we have 179.2 ohms for that thermal. I'm going to hook up the mechanical brake to plus 24 volts DC and see if we can release that mechanical brake. So far, everything is looking good. We're going to use this power supply set to plus 24 volts DC to release that electromechanical brake inside this servo motor. There's 24 volts DC on the meter. That will be our ground. That will be our plus 24. G is the ground, and F is the plus 24. A, B, C, D, E, F, G. All right. That's locked up good and tight. We just applied 24 volts DC to the electromechanical brake, and I heard it release. Did y'all hear it? It clicked. Now we can rotate that motor. So the electromechanical brake is not the problem. We're going to have to hook this servo motor up and try to run it and see what happens. This is the scary part. Okay, here we go. come up UL, because this drive does not recognize that motor part number, so I'm going to push the reset button. When I do so, it goes to BB. Now we're at AB. That's good, we're ready to go. So far, no problem. If we had a problem with the feedback, communications to the drive, we would have got an alarm. So hopefully when I enable the drive, let's see what happens. Okay, I heard the brake release. That means that when I closed RF to plus 24 volts DC, 24 volt DC from the second power supply was routed through the MOSFET inside this drive out to the brake in the motor. Now we're going to close AH and we should get some rotation. Hopefully. There we go, we're moving. Okay, let me stop that motor and I'll put some electrical tape on there so you guys can see it moving. Power down. Men and women, let's try it again. Brake is released. Now we're moving. Let's go the other way. Oh, she's a sweet running motor. Ain't nothing wrong with this motor. She's a sweetheart. Nice. We didn't have to repair that one. Hardest part was hooking it up and testing it. Let me show you the alarm we get if we disconnect that feedback cable. Applying two 20 volts AC 3-phase to the bus power supply. The drive is initializing, and there's alarm 88 with the feedback cable disconnected. And that means error reading motor data, because the motor and drive communicate together. And if the motor does not respond to the drive's communication, you get alarm 88. Okay, I'm going to power down. I'll show you a couple of more alarms that we get. I'm going to turn off the external 24 volts DC to the DAE 1.1 card, applying 220 volts AC 3-phase to the bus power supply. Let's see what alarm we get here. There's alarm 33. Alarm 33 is external power supply error. That's because I don't have the 24 volts applied to the DAE 1.1 card. We power down again. And what can we do next? Let's disconnect the thermal. That thermal is this jumper wire here that connects to the X6 connector. I'm going to turn the 24 volt DC supplies and speed reference supplies on again. And now we have the thermal disconnected. We get a blinking alarm 51. Motor over temperature warning. Now that's the 2 pins would normally be from the motor that we measured that 179 ohms on would be connected to this jumper right here. But I just jump it out right here. Let's see what alarm 19 is. Alarm 19 is motor over temperature shut down. So the drive has shut down because alarm 51 was not cleared. Okay, we're going to plug everything up. I'm applying 220 volts AC 3-phase to the bus power supply. The drive is initializing. And this is the way it comes up if all is well, AB. Now when I close the RF switch to plus 24 volts DC, the brake in the motor is released and we have AH in the 7-segment displays. Now when I close the AH switch to plus 24 volts DC, the 7-segment display shows AF and the motor is running.